The procedural generation of the level starts with a single point, and from there the automata looks for nearby positions that do not belong to other automata. So, like a worm, it creates a tunnel throughout its life. After its death, the system creates seeds in which the player can activate so new automata can be generated in directions on which the automata has not created any of tunnels, and there are vacancies for new tunnels to start. The waves of directional randomization for the automata to choose can be manually set by the designer. This decision of design for level generation came from analyzing two things: maze generation techniques and triangularization. Combining both of them, we could analyze that setting up a system in which neighbor places connect to each other would have a more dynamic and intelligent design to each hint for a grander scheme of the level. But the difficulty of calculation and time wasted for both of them didn't create interesting resolutions. So using transparency, we hide the concept of how the level is generated to fake it out with exploration and data being shown to the player as it is being generated, making it appear as if he is exploring and discovering the level. The other important part of this project is enemies, in which we have implemented pooling and threads. Threads uses the job system of Unity, in which it assigns tasks for the multi-core architecture of modern CPUs, into which we can calculate faster enemy decisions and rigid body velocity changes. The pooling design pattern tries to solve a problem in a Unity architecture, which is the overhead of searching and instantiating a new prefab based on the address of another one. By simply having a list of pre-spawned enemies, we can just activate and deactivate them as we see fit. The player does not need to know how we solve memory solutions and enemy instantiation problems. We have also created the architecture of a menu and loading system asynchronously.